So to end this section, let's talk about how climate change is going to impact the hydrological cycle and rain around the planet and water resources. So first of all, let's see where rain occurs, where we have the rainfall. And this is a map data combination of different satellites, which shows the millimeters per day rainfall from 1979 to 2010. So this is basically all over the planet. And we see that it's not randomly distributed. We know the different patterns, the weather patterns, and you can see the purples and the reds are where we have a lot of the rainfall. You can see over the Western Pacific, Indonesia, in the tropics, South America, Africa, but also at higher latitudes of the Atlantic. And we also have the very dry regions like the Sahara Desert in Namibia in the south. We'll talk a bit more about this later in the course. But basically, we can see the patterns of rainfall, and the question is, how are these going to change, or the water availability, how's this going to change in the future as a result of climate change? Well, even without climate change, we have less and less fresh water to use per capita because the population's growing around the planet. So here we can see on this plot here the renewable fresh water resources per capita for the world, shown in the middle, but also for upper middle income countries, lower middle income and low income in red. We can see that less with time. This is from 1960s to the present, more or less. Less and less water is available for use. Part of this could be climate change, so we have less water available. Part of it could be due to population growth. Whatever the reason, we have less water to use compared with what we had 60 years ago. And so we have to think about how we want to use our water resources in the future, and we're going to have less and less availability of fresh water also because of climate change. So this map is a little complicated, but it shows the areas where we have actually water scarcity around the planet, both physical and economic water scarcity. So first of all, let's start where things are pretty good, in the blue. So this is where we have little or no water scarcity, abundant water resources, and they use less than 25% of the water that they have in those countries like Canada. Also in the Amazon, there's plenty of water, Northern Europe, Scandinavia. So these countries at the moment still are in good situation related to water. If we look at the orange, which is places which are approaching water scarcity, this includes areas not far from here, around about the Middle East, but also Southern Africa. You may remember a few years ago that Cape Town in South Africa, basically the taps went dry. They had no water available because of droughts, and we see the droughts happening also in Europe and in the Mediterranean more recently. So these are countries which are approaching water scarcity, where they basically, at the moment, they're using up to 60% or more of their fresh water for their drinking, for their own uses, for agriculture. The dark reds, mainly we see this in Africa, but also in parts of India and Bangladesh, are places which we have economic water scarcity. These aren't places where there's not water, they're simply badly managed. And so in these places, because of the political systems, the economies, the infrastructures, there's water scarcity, but this is more based on the economy there and less on the climate. So many parts of the world are facing, and there's also, the oranges, the lighter oranges we can see here in this region and over here in Asia, where they do suffer from physical water scarcity, and they're using more than 75% of the fresh water for their domestic use, for agriculture, for industry. If we we break it down into those three areas, we can actually see what is predicted. This is the withdrawal up to 2000. In the top, we see basically the agricultural use by country, and this is given in percentage. How much of the water are they actually using for agriculture? And we can see that it's mainly in the lower latitudes, where in Africa, Australia, Asia, where a large fraction of the water, even in Israel, go to use this for agriculture. If we look for industry, you can see that the Northern Hemisphere, the industrial countries, Europe, Canada, even Russia, use a lot more for industry than than they do for the agriculture. And the domestic use we can see at the bottom. So these are the three main sectors: agriculture, industry, and domestic use, where we need our fresh water. And as I mentioned, not only is population growing, but the climate is changing, and so it's going to put stresses, even more stresses, on countries for use of fresh water. So what's predicted for the future? So here we can see the future precipitation based on models for a 1.5 degree global warming. So this is relative to 1850 to 1900. This is the rainfall or the hydrological cycle. We have positive and negative numbers here. The green means we'll have more rainfall in the future, and the browns and the yellows mean we'll have less rainfall in the future because of a 1.5 degree global warming. And what we see is it's not unlike the temperature, where everywhere we can expect to see warming. With the rainfall, it's going to be different in different locations. Some places are going to get drier, some places are going to get wetter. And again, we're already seeing this around the world. We're seeing droughts in California, in Europe, other places in the world. We're seeing flooding in Pakistan and in China. Some places are getting wetter, some places are getting drier. And basically what we're seeing from all the models is that the hydrological cycle is going to intensify in the future. Where it normally rains, it's going to get rainier, it's going to have more flooding, and where it's dry, like in the Mediterranean, it's going to get drier in the future. What we see on this plot is a percentage change, so it's a little bit misleading, because if it's like in the Sahara Desert, if we have no rainfall, 100% change still means it's zero. So you have to be careful when you interpret these maps. It's not the absolute amount, it's the change relative to what we normally have, but still in places like the Mediterranean, we can expect to see a significant drying as the climate gets warmer. So this is for a 1.5 degree, but we can show this also for a 2 degree warming, the left panel, a 4 degree global warming, the right panel. We see the pictures are basically the same, they just get more intense the warmer it gets. So the warmer it gets, we just get darker greens, darker browns, we have much wetter areas, much drier areas, and things just become more and more extreme with time. And as I mentioned, basically as we go to higher latitudes, we can expect to see more rainfall, like in Europe and in Canada, parts of Asia. The monsoon, that's what we've been seeing recently with the rainfalls in Pakistan, in India, where the monsoons are becoming stronger. Other areas, like in southern Africa, the Mediterranean, California, things are expected to get a lot drier in the future because of this intensification of the hydrological cycle. How do we explain this? How can we have both of these different patterns from a single warming? Well, when things warm up, as we've already spoken about and mentioned, we have more evaporation from the surface. Evaporation from the ocean puts more moisture in the atmosphere, so when we do have rain, more rain falls down. But when it happens over the land, the vegetation loses that moisture and it remains in the atmosphere. So the vegetation, the soil moisture decreases, we have drier conditions, we have drought conditions, which can lead to heat waves and fires and other dry extremes. And if we look at just Europe, the projections for the end of the century, on the left we see the temperature projections, and so we can see that warming everywhere, the data is positive everywhere. But when we look at the rainfall, on the right plot, you can see that basically there's a division somewhere here in the middle of Europe, where to the north of that, we're going to see more rainfall, significantly more rainfall. To the south of that, which is the Mediterranean and where we live here in Israel, we're going to see a decrease in rainfall, quite dramatic decrease. So rainfall is two different signals, moistening, more rainfall, flooding in certain areas, drying in other areas, with temperature everywhere on the planet we're seeing a warming. And one more thing we need to look at when we talk about the hydrological cycle and water usage and water availability is the snow and snow cover that we have, especially in high latitudes, but also in mountain ranges like the Himalayas. A lot of the snow acts kind of as a storage, as a reservoir of water for the spring and the summer. It slowly melts during the spring and summer, allowing people to use this water both for drinking and for agriculture. But what happens if the snow now becomes as rain because it's warmer? Instead of having snow and ice and glaciers, Now we have rain which immediately flows down the rivers and maybe to the sea, and we don't have the storage for the spring and the summer. And here we can see what's happening, the trend on snow cover from 1972 to 2022, looking at this map on the North Pole. So you can see here Alaska and Canada on the left and Russia on the right. And the brown colors are showing the change, the decrease, the negative numbers, the decrease in snow-covered days. So how many days per decade do we have less and less because of the warming? And basically, most places in these high latitudes, you see the brown, less snow cover, less snow days. We can also see the trend in the graph in the top left that this is getting less and less with time. And this could be a big problem for countries which rely on the snow cover and the snow-capped glaciers for their water in the spring and the summer.